For over 70 years, it was the ninth planet in our solar system, a distant icy world on the edge of everything we knew. This is the story of Pluto, discovered in 1930 by the tenacious young astronomer Clyde Tombaugh at the Lowell Observatory. Pluto's existence was initially hailed as a monumental triumph of modern astronomy, the capstone of a long search for a planet X beyond Neptune. But even from the very beginning, Pluto was an oddball. It was perplexingly small, far smaller than even Earth's own moon, and possessed a strange, highly elliptical orbit that was tilted relative to the main planetary plane, even swooping inside the path of Neptune for part of its long journey around the Sun. For decades, these oddities were noted but largely accepted as quirks of the solar system's outermost century. However, as our astronomical instruments grew more powerful and our gaze sharpened on the dark frontiers of the solar system, we began to realize that Pluto wasn't alone. In the 1990s, astronomers started uncovering a vast, sprawling swarm of other icy objects occupying the same region of space. This region, known as the Kuiper Belt, was a cosmic debris field left over from the formation of the solar system. Then in 2005, the discovery of Eris, a distant object in the same belt, brought the issue to a head. Eris was found to be even more massive than Pluto. The question suddenly became urgent and could no longer be ignored. If Pluto was a planet, did that mean Eris was a planet too? And what about the dozens or potentially hundreds of other similar-sized bodies we were likely to find? What truly makes a planet a planet? Faced with a rapidly expanding solar system, the scientific community needed a clear definition. In 2006, the International Astronomical Union, IAU, convened to vote on a formal set of criteria. The resolution they passed stated that for a celestial body to be considered a planet, it must meet three conditions. First, it must orbit the Sun. Second, it must have sufficient mass to assume a nearly round shape due to its own gravity. And third, it must have cleared the neighborhood around its orbit, meaning it has become gravitationally dominant, sweeping up or flinging away other objects. Pluto met the first two rules with ease. It orbits the Sun and it is round, but it failed on the third count. Its orbit is full of other icy Kuiper Belt bodies, a shared space rather than a cleared one. And so, Pluto was officially reclassified, transitioning from the ninth planet to the first in a new category, dwarf planets. The decision was immediately and intensely controversial, sparking debate among scientists and the public alike. To many, it felt like a demotion, a stripping of a beloved status. But in the years since, this new classification has opened our eyes to a whole new class of fascinating worlds. Far from being a demotion, Pluto became the undisputed king of the Kuiper Belt, the prototype for a diverse family of objects that hold keys to understanding our solar system's earliest days. This shift in perspective was cemented when the New Horizons probe flew past in 2015, revealing a stunningly complex and active world with vast nitrogen ice glaciers, towering water ice mountains, and a thin, hazy atmosphere. Pluto's story teaches us that science is a journey, not a destination. It's a process of constant refinement, where new discoveries challenge old assumptions and our understanding of the cosmos is always evolving. No matter its label, this distant, complex, and beautiful world with its iconic heart-shaped plane remains as fascinating and compelling as ever.